Now that you guys have an idea of what ions are and how to determine the charge of the ion that an atom will form, we actually want to take a look at the compounds that the atom will form. Now remember, a compound is simply two or more atoms or ions bonded together. An ionic compound forms when oppositely charged ions stick together. Remember, opposite charges attract. That's why electrons stick with the protons in the nucleus. It's why atoms are neutral, and it's also why an atom has the ability to gain an electron. Those protons will pull on electrons. Okay? And it's the pull of the protons of other atoms that will cause some atoms to lose electrons. So when oppositely charged ions stick together, we have an ionic bond. Opposite charges attract. Okay? So these ions, I have a plus and a minus, they're going to stick together. That's called an ionic bond. And any compounds that's held together by an ionic bond is called an ionic compound. Super creative. Okay? And what's true about an ionic compound, and this is a pretty important part, ionic compounds will overall have a neutral charge. Okay, so the positive ions will get together with enough negative anions so that the charge of the whole thing is neutral. Okay? Now, in order to represent what the compound is, we're going to use a chemical formula. Chemical formulas are those things you see that are like H2O. That tells me hydrogen and oxygen. It tells me what's in it, but it also tells me how many of each thing are in it. So chemical formulas show me what elements are in a compound, and it also tells me the ratio of the elements or the ions in the compound if it's an ionic compound. So the formula will have the element symbols in the compound. So if we had water, you guys are familiar with water, and apparently I can't write pen. Okay. Anyways, you guys are familiar with water. Water has the chemical formula. Okay, water has the chemical formula H2O. And that tells us hydrogen is in it, tells us oxygen is in it, and that little number down there is called a subscript. It tells us that there's two hydrogen atoms with each oxygen atom. So that's all I mean here. And so here's another example, calcium chloride. This is CaCl2. Now this doesn't have a number on it, and just like with the charge, when there's no number, we understand it's 1. Okay, the name of this is calcium chloride. That's the symbol for calcium. That's the symbol for chlorine. Okay, the ending changed to IDE. So calcium ion, one of them, will form in this ionic compound to a ratio of 2 chlorine ions, and the reason for that is the charge, right? Calcium is a 2 plus ion because if we look, calcium has 2 plus for a charge when it gives both of those away. So that becomes calcium 2 plus, and then chlorine, it's a halogen. Whoops, chlorine is not CH, that's a Cl, but let me do that over. Cl has 1, 2, 3, 4, 5, 6, 7. Okay, so 7 here, so it's got an open spot. So calcium's trying to give away 2 electrons, but chlorine can only take 1. And so I have a calcium 2 plus, a chlorine 1 minus. So we can clearly see we're going to need 2 of those to balance that thing's charge. So that's where that ratio comes from. Okay, and always the cation is written first. Okay, the positive ion is always written first, the anion is second. Usually that means we're going to see a metal and then a non-metal. Okay, and the ending of that non-metal, the ending of the anion, is changed to IDE. So that's why it's not calcium chlorine, it's calcium chloride. Okay, now we are going to work an example here, and then you guys are going to have some assignments to do. Okay, so predicting chemical formulas. How do we actually come up with the chemical formula if we know what elements are going to bond? Okay, so this says, suppose potassium forms a bond with oxygen. What will the formula be? Well, let's go find potassium and oxygen on our periodic table, because we need to know what these elements look like. So if I find potassium and oxygen, potassium is right here. It's K. Alright, and it's a 1A element, so I know potassium has 1 valence electron. And oxygen is over here. It's a group 6A element. I know oxygen has 6 valence electrons. So we want to draw their electron dot diagrams to get started. So potassium, capital K, 1 valence electron. And then oxygen, capital O, 6 valence electrons. Okay? Remember, 1 on each side before any side gets 2. Then we're going to figure out what actually happens to the ions here, right? It says draw the electron dot diagrams for the ions. Since potassium wants to give 1 away, potassium will, and it becomes a plus charge. Remember, when I don't write a number, that is a 1 plus. Oxygen will take 2, and if oxygen takes 2 to fill up its open spots, it'll be a 2 minus charge. So now I know what ions I have, and now it's just a matter of bonding them, figuring out what it takes to get to neutral. Okay, and so it's really easy to think about this. I have a 1 plus and I have a 2 minus, so I need to get these two to balance, so I'm going to need 2 of these for every 1 of those. If I have 1 of these, I have 2 minus. If I have 2 of these, I have 2 pluses. So that tells me I need 2 K pluses, so I'm going to write K2O. And if I wanted to name it, K is potassium, and O is oxygen, but I got to change the ending to IDE. So not oxygen and not oxygenide. Okay, that's not what we do. Okay, this becomes potassium oxide. Okay, so K2O is potassium oxide. The formula tells us that there's 2 ions of potassium to every ion of oxygen.